All right, so here we are. We have the integral of ln x dx. So the problem lies in that we know what the derivative of ln x is, but we do not know what the antiderivative is. So we have to use integration by parts. So our u, we have to have ln x. Because if we made our dv ln x, then we wouldn't be able to find v. So we're running into the same issue that we started with. So it has to be our u. And then our dv can be just dx. So now we find the du. Take derivative of ln x, which is 1 over x dx. We can find the antiderivative of dv, which would be our v. So we end up with x is our v. So now we can plug into the formula. So this integral would be equivalent to u v. So if we set them up like this, it's always the diagonal. uv. So x times ln x minus the integral of v du, which is always the bottom ones. So v du so we know that x times 1 over x is just 1. So we are finding the integral of dx. So the antiderivative of dx is just x. So we have x ln x minus x plus c. And we're done. So as soon as you don't have any integration symbols, then we know we're done. All right, let's take a look at another tricky problem here. So in this case, we want to use x squared as our u. So x squared is our u. And then our dv would be everything else. So e to the x dx. All right, so du is 2x dx. Our v, antiderivative of e to the x, is e to the x. Plug into our formula. So this would equal uv. So remember diagonals. X squared e to the x minus the integral of v du. So we have 2x e to the x dx. So if we try to integrate this, the problem becomes we don't know how. So what we have to do is we have to run through a second round of integration by parts. So in this case, we need to identify a u and a dv again. So our u, we're going to use 2x. And for our dv the second time, we are using e to the x dx again. So du is 2 dx. Now we could have pulled the 2 out front if you want and then just have your u be x. We could do that as well. So v would be e to the x. And we run through integration by parts again. So keeping in mind that this is the integration that we're doing right now. Okay, that's the integration by parts. So we need to keep it separate. So we know it's uv. Sorry, not u. So u times v. So 2x e to the x minus the integral of v to u. So that is 2 e to the x dx. So we're going to put this second integration by parts in parentheses because of this negative sign. Okay, everything else drops down. So the negative carries through, and the antiderivative of 2e to the x is 2e to the x. So plus, we have our 2x e to the x, which is minus, and then we have our x squared e to the x. Okay, so a lot of people will mess that carrying this negative through to both those parts there. So make sure we're keeping all that straight. So this would be our final answer right here. So plus c. Okay, so I'm going to stop there and find another hard problem for you to do, a little bit harder than these.